Hello, Mr. Long. This is FRQ number 3. Okay, part A asks us to find or to draw the free body diagram of all the forces acting in the car and also draw an arrow for any acceleration. So here is the car, and then there is Fn, which is a diagonal, and then Fg. And then there is acceleration, there's centripetal acceleration that's pointing to the left. Okay, and then Fn is like that because Fn is the perpendicular force from the surface, and then the surface is like that. So yeah, okay. Part B asks us to derive the normal Fn acting on the car. So I'm going to draw it out real quick. So that's the surface. This is the car, and then we know that the angle is here, and then this is Fn. That is Fny. And this is Fnx, and then the angle will be here. Okay, so we know that since it's not like floating or anything, net force in the y direction is equal to 0. But we also know that net force in the y direction is equal to Fny minus Fg. And then I'll expand Fny to Fn sine theta because we figured out that it's there, and then Fny is opposite of the angle. So minus Mg is equal to 0. And then add Mg over Mg, and then I say for Fn, we just divide sine theta. Fn is equal to Mg over sine theta. Okay, but we can also look in the x direction. So net force in the x direction is equal to Fn cosine theta, but net force in the x direction is also equal to Fc, which is equal to mv squared over r, where r is this. And then, so to figure out what r is, the diagram is like this. The angle there, and then this is h, and then this is r. So r over h is equal to tangent theta. And then to isolate for r, you just multiply h to both sides. So r is equal to h tangent theta. So here we can replace r here with mv squared all over h tangent theta. Okay, and then now we can equal both equations to each other. So Fn cosine theta is equal to mv squared all over h tangent theta. And then here I'll break up tangent theta to sine theta over cosine theta. And cosine theta is equal to mv squared all over h sine theta over cosine theta. And the cosine theta will flip over to the top of the fraction. So Fn cosine theta is equal to mv squared cosine theta all over h sine theta. And then the cosines from both sides will cancel out, so you're left with Fn is equaling to mv squared all over h sine theta. Okay, it's part B. Part C asks us to find an equation for Fc. So we know that found earlier in this we know that Fc is equal to mv squared all over h tangent theta, but we also know that Fc is equal to Fn cosine theta, and then we also found what cosine equal to, or not cosine, sorry, we found out what Fn equal to, which was mg over sine theta. So replacing that, we're left with mg over sine theta times cosine theta, and the cosine theta over sine theta is cotangent theta, so Fc is equal to mg cotangent theta. Okay, part D. Part D asks us to derive an expression for V in terms of given quantities. Since we found what in part C what Fc is equal to, we can just equal these two equations to each other. So mg cotangent theta is equal to mv squared all over h tangent theta. And then m's will cancel out from both sides, and I'll just multiply h tan theta to both sides. So we have g h cotangent theta times tangent theta is equal to v squared, and then cotangent theta and tangent theta will cancel out. So if gh is equal to v squared, and to isolate for v, we'll just screw it with both sides. So rad gh is equal to v. Okay, so part E asks us to find v max. So then v max is pointing downwards to keep it from flying off into a tangent, the car. So v max is like, this is, friction is pointing downwards, so the car wouldn't be flying off into a tangent. So that's v static friction. This is fsy, and this is fsx, and the angle would be here. So but then the net force in the y direction is still 0, but now it's equal to fny minus fsy minus mg, which equals 0. And then breaking up fny is be fn sine theta minus fs cosine theta, because since we determined the angle to be here, not there, the angle should be down here. So fs cosine theta is equal to mg, moving mg over there. And then I'll break up fs into mu s fn. So fn sine theta minus mu s fn cosine theta is equal to mg, and then factoring fn from both terms on the left side. So fn times sine theta minus mu s cosine theta is equal to mg, and then isolating for fn, so dividing both sides by the parentheses. So mg all over sine theta minus mu s cosine theta. And now in the x direction, net force in the x direction is equal to fnx plus fsx, and they're adding now because fnx is pointing to the center, and fnx is pointing to the center, and fsx as well. But we also know that net force in the x direction is equal to mv squared over r. So equaling those two equations together, we're left with this, mv squared all over r, and then I'll break up fnx into fn cosine theta, and then breaking up fsx into mu s fn sine theta is equal to mv squared all over r. And then I'll factor out fn from both terms on the left side. So fn times cosine theta plus mu s sine theta is equal to mv squared all over r. And then here I'll just isolate for fn again. So fn is equal to mv squared all over r times cosine theta plus mu s sine theta. And then I'll equal the two fn equations that we just found. So mg all over sine theta minus mu s cosine theta is equal to mv squared all over r times cosine theta plus mu s sine theta. So then m's will cancel off from both sides, and then I will multiply the bottom of the right side to the left side to isolate for v squared. So it'd be gr times cosine theta plus mu s sine theta all over sine theta minus mu s cosine theta is equal to v squared. And then I'm just gonna, on the left side, I'm just gonna divide everything by sine. So it'd be gr times cotangent theta, because cosine theta over sine theta is cotangent theta, plus mu s all over 1 minus mu s cotangent theta is equal to v squared, and then isolate for v max, you just square root. So square root, or gr cotangent theta plus mu s all over 1 minus mu s cotangent theta, square root of that is equal to v max. Okay, part F asks us to do basically the same thing, but instead solve for Vmin. So here, looking back at the drawing, instead of fsx being there, it's going to be up here, and then it'd be like that's fsy and that's fsx. So fsy will be pointing up with fny, and then fsx and fnx are now opposing each other, and then the angle will be here. Okay, so same thing, net force on the y is equal to fny plus fsy now minus mg is equal to 0. And then we're going to move over, break up fny again to fn sine theta, and then fsy into mu s fn cosine theta, and then I'll add over mg, and then factor out fn again. So sine theta plus mu s cosine theta is equal to mg. So, and then to isolate for fn is equal to mg all over sine theta plus mu s cosine theta. And then x direction is like in the previous part, but fnx and fsx are now opposing each other because fnx minus fsx, which is equal to mv squared over r. And then so breaking up fnx into fn cosine theta minus mu s fn sine theta is equal to mv squared over r. And then once again factoring out an fn on the left side, cosine theta minus mu s sine theta is equal to mv squared over r, and then isolating for fn. So fn is equal to mv squared all over r times cosine theta minus mu s sine theta, and then equaling the two fn equations again to each other. So mg all over sine theta plus mu s cosine theta is equal to mv squared all over r cosine theta minus mu s sine theta. M's will cancel from both sides, and then to isolate for v squared, we're just multiplying the bottom of the right side to the left side. So it would be gr times cosine theta minus mu s sine theta all over sine theta plus mu s cosine theta is equal to v squared. And once again, like the previous part, I'm just going to divide everything on the left side by sine theta. So it would be gr times cotangent theta minus mu s all over 1 plus mu s cotangent theta is equal to v squared. And then to find vmin, you just square root it. So it would be gr times cotangent theta minus mu s all over 1 plus mu s cotangent theta radical is equal to v min. Okay, part G asks us to prove that the net force of the function is f net is equal to cotangent theta plus mu s all over 1 minus mu s cotangent theta times mg. Okay, so starting once again in the y direction, we know that net force in the y direction is equal to fn sine theta minus mu s fn cosine theta minus mg, and then fn, which is basically like earlier, we isolate to get fn is equal to mg all over sine theta minus mu s cosine theta. It's the same process as in part E, I'm pretty sure. Yeah, part E. And then here, net force is equal to net force in the x, because of the net force in the y, it equals to 0. They cancel out. All the forces in the y direction cancel out. So you can just look in the x direction. So we know that net force, now is equal to fn x plus fsx, and then that will expand into Fn cosine theta plus mu s Fn sine theta, and then once again factoring out Fn from it, so we got net force is equal to Fn times cosine theta plus mu s sine theta, and then we replace Fn with what we found earlier in this part, so net force is equal to mg all over sine theta minus mu s cosine theta times cosine theta plus mu s sine theta, and then we can rearrange it to look like this: mg times cosine theta plus mu s sine theta all over sine theta minus mu s cosine theta. And then just like in the two previous parts, we're going to divide everything by sine. So net force is equal to mg times cotangent theta plus mu s all over 1 minus mu s cotangent theta, which matches up with what they wanted us to prove. Okay, that is FRQ 3.